completed rule 1, rule 2 and rule 3. Now let us move on to rule 4. So in rule 4, we are trying to find out the number of asymptotes, which is denoted by n. Okay. In rule 4, we are trying to find out the number of asymptotes n. So what are these asymptotes? So we all know from rule 1, always a root locus starts from a pole and it terminates at 0. In the given transfer function, if the number of zeros and poles are not equal, if zeros are greater than pole or if poles are greater than zeros, then definitely the poles present in the transfer function should meet at infinite 0. So how these poles will go and meet at infinite 0? So this particular path is directed by a straight line which is called as asymptote. Okay? Asymptotes are nothing but the line which guides the path of a pole to meet infinite 0. Now in the given transfer function, I need to find out how many number of asymptotes do we get, that is how many number of poles are terminating at infinite 0. For that we have 3 different cases. So under case 1, if P is greater than Z, P is nothing but number of poles, Z is nothing but number of zeros, then the formula to find out the number of asymptotes will be equal to P minus Z. Clear? So similarly, the second one, if Z is greater than P, then n is equal to Z minus P. Okay. Third one, if P is equal to Z, which means that the number of poles and the number of zeros are same, then we will not get the asymptotes, because all the poles present in the given transfer function are terminating at the zeros present in the given transfer function. These are the 3 different cases. So one case is if P is greater than Z, n is calculated using the formula P minus Z. If Z is greater than P, then n is equal to P minus Z. If both are equal, as I said, n will be equal to 0. That is, the number of asymptotes is nothing but equal to 0. So taking this example, in this example, as we calculated according to rule number 1, P is 4 and Z is 0. Okay. Under which condition or which case do this come? P is greater than 0, that is case 1, P is greater than Z. Okay. If P is greater than Z, the formula to calculate n is P minus Z. Therefore, n is equal to P minus Z, which is equal to 4 minus 0, which is equal to 4. Therefore, all the 4 poles are meeting at infinite 0, because we don't have any 0 in the given transfer function. Therefore, definitely all the 4 poles should meet at infinite 0. By this we can tell there are 4 asymptotes. Okay. Now rule 4 is clear. Now I need to find out at what particular point all these 4 asymptotes are intersecting. Okay. So that is done in rule number 5. In rule number 5, we try to find the centroid of asymptotes. Which is denoted by sigma. Okay. So in rule 5, I need to find out the centroid. What is centroid of asymptotes? Centroid is nothing but a point where all the asymptotes come and intersect. Okay. In order to do so, the formula is sigma, which is equal to summation of real part of poles in the given transfer function minus summation of real part of 0 whole divided by P minus Z. Okay. So this is the standard formula which we are going to use in order to find out the centroid of asymptotes. Okay. What is centroid? Centroid is nothing but a point on the real axis where all the asymptotes come and intersect. That is nothing but the centroid. Now to this example, let us try to find out the centroid. Okay. So in this example, we know the location of poles are at, we had P was equal to 4 and they were at S is equal to 0, minus 4, minus 2 plus J4 and minus 2 minus J4. Okay. And Z was equal to 0. Let us substitute in this formula. Sigma is equal to sum of real part of the poles. Okay. That is 0, minus 4, minus, in this the real part is minus 2, minus 2, in this the real part is minus 2, minus sum of real part of zeros, that is nothing but the location of zeros. Do I have zeros? No. If I don't have zeros, definitely I am not going to get the location of those zeros. So it is 0. So what is P? The value for P is 4 minus the value for Z is 0. So if I simplify this, minus 4 minus 2 is minus 6, minus 6 minus 2 is minus 8. So minus 8 divided by 4, which is equal to minus 2. Therefore, for this example, the centroid is located at minus 2, which means that at this particular point, all the asymptotes come and intersect. So this is centroid. You need to mark and you need to write it as, you can just write it as sigma, which is equal to minus 2. Okay. Now we completed rule number 5. Now I need to find out at what angle all these asymptotes are meeting at infinite 0, which is nothing but rule number 6, where we try to find out the angle of asymptotes. I need to find out the angle, so which is denoted by theta. Okay. The formula used to find out the angle of asymptote is 2 theta is equal to 2q plus 1 into 180 degree divided by P minus Z, where Q is nothing but 0, 1 up to P minus Z minus 1. So this is the formula which you people should remember in order to find out the angle of asymptotes. Now, taking the example which we took and we have constructed the root locus until the centroid part, we will continue with the same example. So the example which we had taken was G of S into H of S, which is equal to K divided by S into S plus 4 into S square plus 4S plus 20. Okay. Now, in this we know the value for P is 4 and the value for Z is 0. If I try to find out Q, Q will be equal to 0, 1 up to 4, P value is 4 minus Z is 0 minus 1. So 4 minus 0 is 4, 4 minus 1 is 3. So Q ranges from 0, 1, 2 and 3. From 0 to 3. Now I need to substitute the values of Q as 0 in this equation, which gives us the first angle of the first asymptote, then 1, then 2 and 3. Let us try to find out the angles. If Q is equal to 0, then theta will be equal to 2 into 0 plus 1 divided by 4 minus 0 into 180. So which is nothing but equal to 180 by 4. Okay. So 180 by 4 is nothing but equal to 45 degree. Okay, the first angle what we get is 45 degree, which means that the first asymptote is moving at an angle of 45 degrees. Similarly, I need to find out the 3 more angles, that is theta 1, theta 2 and theta 3 by substituting the values of q as 1, 2 and 3. If I substitute the value of q as 1, if q is equal to 1, the next value theta will be equal to 2 into 1 plus 1 whole divided by 4 into 180. 2 ones are 2 plus 1 is 3. So which is nothing but equal to 3 into 180 divided by 4, which gives us 135. Okay. Now if q is equal to 2, theta will be equal to 2 into 2 plus 1 divided by 4 into 180 degree, which is equal to 2 2s are 4, 4 plus 1 is 5. So it is 5 into 180 divided by 4, which gives us 225 degrees. Okay. The last value for q is equal to 3, theta is equal to 2 into 3 plus 1 divided by 4. 2 3s are 6, 6 plus 1 is 7 into 1, this should be 180. So this will be equal to 7 into 180 divided by 4, which is equal to 350. Okay. Now we got all the angles for all the 4 different asymptotes. Now what I need to do, take a protractor, keep the protractor centered at centroid sigma is equal to -2. So if I keep a protractor here and I need to measure the first angle as 45. So the 45 degree comes somewhere here. Okay. This is 45. Similarly, I need to measure 135. 135 degree comes some here. That is, from this point to here, the angle is 135 degree. 45 is completed. 135 is completed. The second angle made is 225. So I need to keep the protractor here and I need to measure 225. So from here till here, the angle made is 225 degrees. Okay. The last angle is 315. So keep the protractor centered at centroid and mark 315. From here till here, the angle made is. So like this, we need to write or we need to plot all the angles of the centroid on the graph sheet. So this completes rule number 6. Moving on to rule number 7, which speaks about breakaway and break-in point. So what is breakaway point? So now looking into this graph, so I know this pole, it is located here. So this pole cannot move towards left hand side because from -4 to -infinity, the real axis is not part of root locus. Therefore, this pole has to move in this direction only, in the forward direction, that is towards right hand side. Similarly, this pole cannot move towards right hand side because this real axis is not part of root locus. Therefore, this pole has to move in the left hand side direction. Now, these two poles are moving in opposite direction on the same plane. Therefore, they collide at some particular point. That collision point is nothing but called as breakaway point. Now, in this example which we have taken, let us try to find out the breakaway point. So, in order to find out the breakaway point, the first step is we need to find out the characteristic equation . So we all know the characteristic equation is nothing but it is given by 1 plus g of s into h of s, which is equal to 0. Okay. So this is the first step, that is finding the characteristic equation from the given transfer function. The second step is to find out the equation from this characteristic equation for k in terms of s. Okay. So find equation for k in terms of s. Clear? So after finding out the equation for k in terms of s, the third step is to differentiate that equation, that is the equation of k, with respect to s and equate it to 0. So this is the third step, that is differentiate the obtained equation for k with respect to s and equate it to 0. So once you differentiate and you equate that equation to 0, you get a equation. Okay. This equation or the roots of this equation gives breakaway or break-in points. The method for finding breakaway and break-in are same. Okay. Now this is the fourth step, that is after differentiating and equating it to 0, you get an equation. So the roots of that equation is nothing but a breakaway and break-in point. Now I need to find out which is a valid breakaway and break-in point. So this gives the break-in and breakaway point for the range of k from minus infinity to plus infinity, but I need to find out which is the valid breakaway point. In order to find out the valid breakaway point, the last step, valid breakaway or break-in point. So what should I do? Okay. So whatever roots I have got in this equation, that is the values of s, whatever I have got in this equation, I need to substitute all those equation in the equation of k. If the value of k, after substituting the value of s in the equation of k, is positive, then it is a valid breakaway or break-in point. Or if the value of k is negative, then it is invalid breakaway point or break-in point. So like this we can find out the breakaway points. Now let us take an example. So, and we will find out what are the breakaway points. The example which we have taken is g of s into h of s, which is equal to k divided by s into s plus 4 into s square plus 4s plus 20. Clear? Now what is the first step? Find the characteristic equation. So this is the standard characteristic equation, that is we know that 1 plus g of s into h of s, which is equal to 0. This is given g of s into h of s. Substitute it here. 1 plus k divided by s into s plus 4 into s square plus 4s plus 20, which is equal to 0. Now I need to simplify this. After simplifying the equation, what you get is nothing but the characteristic equation for the given transfer function. After simplifying this equation, this is the equation which we are going to get, and this equation is nothing but the characteristic equation. Now the first step is done, finding the characteristic equation. What is the second step? From this characteristic equation, I need to find the equation for k in terms of s. You need to find the equation for k in terms of s. So I will keep k in the left hand side and move rest of the term towards right hand side. This becomes minus s power 4 minus 8s cube minus 36s square minus 80s. Let us term this equation as equation star. Clear? So this step is done. This step is also done. So in the third step, I need to differentiate the equation of k with respect to s and equate it to 0. So differentiate equation star with respect to s and equate it to 0. This term will be dk by ds, which is equal to minus 4s cube minus 24 s square minus 72s minus 80. Now what I can do? I can equate this to 0. Later in this equation I can take minus 4 as the common factor. So after taking minus 4 as the common factor, that minus 4, if I move towards right hand side, that becomes 0. This is the equation which I am going to get after taking minus 4 as the common factor and moving it towards right hand side. Now if I try to find out the roots of this equation, the roots of this equation will be equal to minus 2 plus j 2.45 minus 2 minus j 2.45. These are nothing but the roots of this equation. So until where I have completed? So characteristic equation we found out. Equation for k in terms of s, it is also done. Differentiate the equation of k with respect to s and equate it to 0, that is also done. Then you get the equation. We got this equation after differentiating and equating it to 0. Then the roots of this equation gives us the breakaway and break-in point. So these are nothing but the roots of this equation. Therefore these are nothing but the breakaway points. Now out of all these three, what I need to do? I need to find out which is the valid breakaway point. In order to do so, what I should do? I should substitute the value of s as minus 2 in equation star, and I should check what value of k I am going to get. If k is positive, then it is a valid breakaway point. If k is negative, it is invalid breakaway point. Now let us substitute the values of s. That is, when s is equal to minus 2 in equation star, k will be equal to, wherever you have s, you need to substitute the equation star. That is minus of minus 2 to the power of 4 minus a to the power of minus 2 cube minus 36 into minus 2 square minus 80 into minus 2. If I simplify all this, the value for k, what I am getting is 64. Therefore, the point s is equal to minus 2, that is the point on s plane at minus 2 is a valid breakaway point. So this is a valid breakaway point. Similarly, I need to check for the other two, that is when s is equal to minus 2 plus j 2.45 n star. Substitute in the similar fashion and find the value for k. The value for k is 99.99. Okay. So this is the value which we are going to get. Similarly, when I substitute the value of s as minus 2 minus j 2.45 in star, the value for k will also be equal to 99.99. Therefore, all the three roots of the equation are valid breakaway points. Now, let us see. So, the first valid breakaway point is minus 2, which means that this pole is coming like this and this pole is coming like this, and these two are colliding at minus 2. So, let me mark it. So, here breakaway point, the first breakaway point, which is at minus 2. Okay, that is the valid breakaway point. After breaking at this point, one pole will move like this and the other pole will move like this. Okay, and we have two more poles here. but I don't know at what particular angle this pole is moving and this pole is moving. So in order to find out at what particular angles the complex poles are moving, we need to find out an angle which is called as angle of departure. If we have complex zeros, then it will be angle of arrival. Now in the next rule, let us try to understand how to find out angle of departure and angle of arrival.